is simplifying radicals. What we want to do is find the largest perfect square factor that divides into the radicand, and then we're going to rewrite the radicand using that perfect square factor, and then we're going to take that one out. Now, it sounds kind of complicated, but it's actually not. The main thing is we're going to use this product rule, and we're also going to have to remember the fact that a squared of b is the same as a times the square root of b. We're going to do some examples to help you understand what's going on. So we're not finding decimals. Keep that in mind. This is not simplifying or evaluating by finding decimals. This is simplifying by removing perfect square factors. So when we look at square root of 40, there's no number squared that gives us 40. That's a nice number, that is. And so we're going to think, what are all the numbers that can divide into 40, and what's the largest number that's a perfect square? Now when you think of perfect squares, you think of numbers like, I could use a 1, I could use 0, but really you're going to start thinking 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on, so on, so on. Now these numbers get big really quickly, so be aware. So what I'm going to do is, one approach is actually just to take that 40 and start listing all the factors of 40. So you can do 1 and 40, you do 2 and 20, 3 won't go, 4 goes 10 times, and 5 and 8. Now one of those is a perfect square. If I had more than one, I'd use the biggest, but only one of those is a perfect square, and that's the 4. So what that means is I'm going to take that 40, rewrite it as 4 times 10. And then what I'm going to do is I'm going to use the product rule and rewrite that as the square root of 4 times the square root of 10, because they each get their own square root. Now I always write this perfect square number first. The reason being is it helps you understand how to write the answer, or the final answer. Then we find the square root of the perfect squared number. In this case, the square root of 4 is 2, and the square root of 10 stays. Now the better you know your times tables, the faster these are going to be. For example, when you look at the square root of 18, if you know your times tables, you know your perfect square numbers, you'll know that 9 goes in 18. You could also do this. You could also take your list of perfect square factors and start thinking, which of these, what's the biggest number that divides into 18? Does 4 go? No. Does 9 go? Yes. 16? No. 25 is too big, so 9 is the biggest one. So what that means is, I'm going to rewrite 18, or square root of 18 as the square root of 9 times 2, because 9 times 2 is 18, and 9 is a perfect square. So I'm going to separate it, each with its own square root, and find the square root of 9, which is 3, and the other number stays underneath the square root, and we get 3 square root of 2. Now there's a faster way of doing these. If you ever seen the Oscar-winning movie Mad Max Beyond Thunderdome, you may have heard the phrase, 2 men enter, 1 man leaves. Well, that's what's going on here. 2 men enter, or 2 numbers enter, and 1 man leaves. In this case, one of the numbers has to be a perfect square, and that's the number that leaves. To show you that, before I do the square root of 80, I'm going to do a little bit of one that's maybe a little bit easier to do. Let's just do the square root of, I'm trying to think of small numbers that you can get. Square root of 20. Square root of 20. If you think about it, 4 is the biggest number that divides into 20. That's a perfect square. So that's the same as square root of 4 times 5. 2 men enter. Guess which one leaves? The 4 is going to leave because the square root of 4 is 2. 5 stays. 2 men enter, 1 man leaves. That's like doing that. 80 is a little different. And the reason why 80 is different is because it has more than one perfect square factor. In fact, let's list all the possible pairs of factors for 80. So we got 1 and 80, 2 and 40, 3 won't go, 4 goes 20 times, 5 and 16, 8 and 10. Now if you look, 4 is perfect square, but so is 16. So if you use 5 times 16, you got nothing to worry about. But let's just say that you don't. Let's just say that you're thinking using your list of perfect squares and seeing which one divides into 80. Let's say you come up with 4 times 20. Let's just say, what if? So you wrote 80 is 4 times 20. And you know that 4 comes out as a 2 because the square root of 4 is 2. And 20 stays. Well, you're not done, because the 20 also has a perfect square factor. So we gotta simplify 20, because that's the same as 4 times 5. We just did that one. Now the square root of 4 comes out as a 2, and the 5 stays. Now, up here you'll notice that a squared root of b is the same as a times square root of b. And what that means is this is 2 times the square root of 5. And 2 times 2 is 4. So we end up with 4 square root of 5, which is the correct answer. But let's just say that you realize that 16 was the biggest one, the biggest perfect square factor of 80. So instead of using 4 times 20, you used 16 times 5, which is what you want to do. And the reason being is the 16 comes out as a 4, and the 5 stays. Same answer, fewer steps if you use the biggest one. It's not wrong if you use the smallest, it just requires more steps. So always use the biggest if you can find it. That's my suggestion for the day.